Hi guys, salut les gars. Welcome to Basics Math. Bienvenue sur les maths de base. Today is episode 14. Aujourd'hui c'est l'épisode 14. So, as we have seen yesterday, we have seen a link between geometry and algebra, and now we can talk about algebra. Comme nous avons vu hier, il y a un lien entre la géométrie et l'algèbre, et à partir d'aujourd'hui, on va continuer sur l'algèbre. So, let's take an example from real life. Donc, prenons un exemple de la vie réelle. We've got several units to measure temperature. Nous avons plusieurs unités de mesure de la température. First, we've got the Fahrenheit notation used in US and Canada. And in Europe and other parts of the world, we use Celsius degree. Donc d'abord, nous avons les degrés Fahrenheit utilisés aux États-Unis et au Canada, et en Europe et dans d'autres régions du monde, on utilise les degrés Celsius. So here is a link between these two two quantities. 1 degree Fahrenheit equals 1 degree Celsius times 9 on 5 plus 32. Donc 1 degré Fahrenheit est égal à 1 degré Celsius multiplié par 9 sur 5 plus 32. So, if we've got x for degrees Celsius and y for degrees Fahrenheit, we can write a formula. Y equals 9 on 5 times x plus 32. So we've got a relationship between degrees Fahrenheit and degrees Celsius. Donc nous avons une formule qui relie les degrés Fahrenheit au degré Celsius. Okay, so we can do better than that. We can make a representation of that using a coordinate system. What's a coordinate system? Nous pouvons faire mieux que ça, nous pouvons faire une représentation graphique de cette relation grâce à un système de coordonnées. So, here is a graph. We've got two axes. We've got an horizontal axis called x-axis. Nous avons un graphique avec deux axes. Un axe horizontal qui s'appelle l'axe des x ou axe des abscisses. And we've got a vertical axe which is called y-axis. Et nous avons un axe vertical qui est appelé l'axe des y ou axe des ordonnées. The way to represent points on this map, la façon de représenter des points sur cette carte, is to choose one number for x-axis, for example, let's choose 4, and one number for y-axis, let's choose 5. Donc une façon de représenter les points sur cette carte, c'est de choisir un premier nombre pour l'axe des x, et un deuxième nombre pour l'axe des ordonnées. So for example, let's say we have the point A, coordinate 4, 5. It's 4 steps on the right, on the x-axis, and then 5 steps to the up on the y-axis. We've got the point A. That's the way of representation. We choose a number for x and a number for y. Donc 4 pas vers la droite, puis 5 pas vers le haut, c'est la façon de représenter le point A de coordonnées 4, 5. Donc nous avons cette façon de représenter qui est de choisir un nombre sur l'axe des x et ensuite de choisir un nombre sur l'axe des y. As we can see here, we've got a link. For example, if we choose x equal 5, we've got 9 on 5 times 5 plus 32. 9 on 5 times 5 equals 9. 9 plus 32 equals 41. So we've got y equals 41. So we've got this link. Let's call this point C. C is 5, 41. So we can represent this point like this. We can choose x equals 0, and we've got 9 on 5 times 0 plus 32, so we've got 32. So y equals 32, so we can choose a number like a point like D, and it's 0, 32. And we can choose x equal minus 10, and we've got 9 on 5 times minus 10 plus 32, which is equals to minus 9 times 2 plus 32, which is equals to minus 18 plus 32, which is equals to plus 14. So we've got the point called E, minus 10, 14. And we can do it and so on. So let's do this here. Y equals 9 on 5. Let's make a quick calculation here. 9 on 5. Donc, faisons un petit calcul. 9 sur 5. It equals 9 times 2 on 5 times 2, which is equals to 18 on 10, which is equals to 1.8. So we can write 1.8 times x plus 32. And we've got a line. We have to change the scale, and now we can find this. If we put, as we have done, let's go back to our first calculation. We say C is 541. So let's put 541. We can see here is on the line. We can do other calculation. It was D 032. So let's put D equals 032. Okay. And E, which is equal to minus 10, 14. And we've got the 3 points on the line. So we get a line that represents all the temperature in Fahrenheit degrees when we know Celsius degrees. Okay. So what are the properties of this kind of function? Because this kind of relationship is called a function. We know y in function of x. We've got this relationship. F, take x and transform it in y equals 1.8 times x plus 32. That's this relationship. And we can calculate a lot of numbers. Let's take a table. For example, here we've got x, and here we've got y. Okay. So here, let's assume we start with minus 30. And here we've got f of minus 30. Okay, here we've got these guys plus 5. Okay, so now we can have a look of some points. And if we represent them. They fit all in the line. Okay? This kind of function calls affine function. The general form of this is f of x equals m times x plus p. And in this case, m equals 1.8, sorry, and p equals 32. We've got specific calculation. For example, we've got two special points. First is f of 0. F of 0 always equals m times 0 plus p always equals p. So in this case, 32. And we've got an equation is f of x equals 0. So we can solve it. M times x plus p equals 0. First, we make minus p on each side. Okay, we've got plus p minus p here. So we can cancel them. So we've got m times x equals minus p. And now we can divide by m, and we've got m times x on m equals minus p on m. So we can cancel them. And we've got x equals minus p on m. And for example, in this case, it's minus 32 on 1.8. We can take a calculation, and we've got around minus 17.8. Okay, let's check on GeoGebra. We don't need the table anymore. So let's have a look. Here we go. And we've got exactly what we say, minus 17.78. If we choose to add more digits, we can see that's again a 7. And if we do more digits, we can do 5 digits. We got 7, 7, 7, 7, 7, 7, 8. Okay, so we can have this property. Okay, but let's go back to our specific function. We've got y equals 9 on 5 times x plus 32. So that's Fahrenheit degrees when we know Celsius degrees, but sometimes we have to do the reverse. We know the Fahrenheit degrees and we want to know the Celsius degrees. So how can we manage it? How can we solve it? That's simple. The purpose is to express x in function of y. So that's a reverse time. So we have to solve this equation. First of all, we have to get this guy on the other side. So let's write it on this side. The purpose is to find x. Okay? Okay. So let's do this. Minus 32 equals y minus 32. We can cancel here, and we've got 9 on 5 times x equals y minus 32. Okay, let's continue. We have to get out this stuff. Okay, we can multiply by 5 and divide by 9. Let's do this. Here we can cancel this and cancel this. So we've got x equal 9 on 5y minus okay, 9 times 32 it equals 18, and this. Okay, so here we go, we have a new function, it's called 9 on 5 y minus this. But the variable, its name is not important, because variable could be named x, z, or whatever. So usually we like to use x for the variable and y for the result. So let's say that g of x is 9, it's 5 on 9 and not the reverse. Sorry for that. Five on 9. So it's here not on 5 but on 9. It's 5 on 9 times 32. So let's make the calculus. Sorry. 5 times 32, it's 0, 160 on 9. So that's 5 on 9, 100 on 9. Okay, and here is the same. 5 on 9, x minus 160 on 9. Let's check it out. Okay, here we go. It's 5 on 9. So let's use parentheses. Times x minus 160 on 9. Let's change the color. Use this, and for this let's use that color, and for this let's use this. Let's go back to 2-point digits. That's largely enough. Okay, and let's have a look. We've got a kind of symmetry. We don't need this point anymore. So let's, okay, but now we've got a kind of symmetry here. Here we've got a symmetry. This line is important. We can see the symmetry here. Okay, so we can find the reciprocal function by using this symmetry. And we can do it by calculus. So let's analyze what we've done. Let's do some example. We've got the formula 1.8 of x plus 32, or if you prefer with fraction, 9 on 5 times x plus 32. Let's assume we've got y equals to 40. So that's 40 degrees Fahrenheit. And we want to know how many Celsius degree we have. Of course, what we have to do is to solve this equation. The equation is 9 on 5 times x plus 32 equals 40. Okay, so let's do the same. First, we have to cancel this 32. So we do minus 32 on each side of the equation. Second, we can cancel it. Okay, we've got 9 on 5 times x equals 8. So now we have to cancel this. And to cancel this, we have to multiply by 5 and to divide by 9. So we've got up, cancel, 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 and we've got x equals 40 on 9. That's precisely what we have done with the formula, the general formula. So let's have a look at the general formula. So the general formula was y equals m times x plus p. So if we want to get x, we can do this. First, minus p on each part of the equation. So we can cancel them. Second, we have to divide by m. So we've got x equals y minus p on m. So we always have this relationship if we've got f of x equals m times x plus p. The reciprocal calls f to the minus 1 equals of x minus p on m. Now we can have a general formula. Let's look about this. So let's do a new one. Okay, let's use here for m and here for p. So we can manage and change values. First, we've got f of x, which equals m times x plus p. So we can have a look about what is the effect of changing m value and the effect of changing p value. We can observe that when we move p, the line just go up or down, and when we change the m value, it rotates. Okay, that's not the same effect, but that's not the purpose of this video. Okay, so let's have a look about the reciprocal. The reciprocal, we say, let's call it g of x is x minus p divided by m. Okay? Okay, and now let's change the color. Okay, let's use this color. Okay, and let's introduce this axis, the axis of symmetry, and we can see that whatever the value of m, this axis is always a symmetrical axis of these two guys. That will be the purpose of the next video. See you tomorrow for the solution of this problem, but you can make some guess.